Hi and welcome back. So today we are going to do 2D vector practice problems for physics. Essentially, you start doing these problems in say grade 11 or 12, depending on the school system you're in. So we're going to do a really simple practice problem, and we'll go through it, all the steps, and you'll see how you can find vector displacement in 2D. So my question today is, a car drives 42 kilometers in the specific direction, so north 25 degrees east, and then it goes on to drive 37 kilometers south 42 degrees east. Oh, let's write that better. South 42 degrees east. And then finally it drives 26 kilometers south 12 degrees west. So say you were given a question like this. So it gives you, as you can see, three what are displacements, right? So three displacements in three very different directions. So how do you find out the final displacement? Well, you break them up into components. So first off, as with any physics vector problem, we are going to assign our directions. So we're going to say going up is north, and hence that makes this way east, and so on. And we're going to define the upward direction as a positive y, right? And going towards your right as positive x. So always start off with defining your directions. Just you can make you can take up a little space on the right hand corner of your page and start off by defining these directions. Secondly, you want to make a table listing your vectors out. So we have three vectors, right? So let's write, you're going to have one column that's going to define your vectors. Then you're going to have another column which you're going to define your x component vectors, because remember, we have to break every vector down. So your x component vector, and then you're going to have your y component. So I'm just going to write y component here. We have three vectors, so we're going to need three rows. So 1, 2, 3, and then we're going to have a final one for the sum of all the vectors, right? So always set up your table like this. Obviously you can make it neater than mine because I'm doing it on the computer. Let's start off with vector 1. So vector 1 is pretty simple. It's going 42 kilometers in the north direction, so that's your positive y, so we can call it d1y. So it's displacement in the y direction for vector 1, so d1y. Just, you can call it anything you want. Just make sure it's something logical so you'll be able to follow along your problem. I'm going to call it d1y. So we have d1y, in which you have north, and then you have an east component, so which is the x component. We can call it d1x. Similarly, and we can also so obviously we know this is 42 kilometers because it's already defined in the problem. That's the final displacement. But we've broken it down. We have d1y, we have d1x. We obviously know this is a 90-degree angle right here, and we also know what this angle is. This angle is 25 degrees because that is a given. So how do we figure out d1y and d1x? Well, that's your simple trig problem right there, a trig problem from like grade 9. So we can start off with, say, d1x. So you can say d1x. What relationship would you use? You need d1x. You have your hypotenuse, which is 42, and you have an angle at this point here. So in my opinion, we should use the sine relationship. So we can say sine theta times your hypotenuse is your d1x right here. Now, if you've forgotten how to how to manipulate your trig relationships, I highly suggest you go back and review those, because you're going to be using a lot of trig in analyzing vector components. You need to be comfortable with your trig. Not so much identities for now, we'll get into that later, but definitely your basic trig relationships, so your sine theta, your tan, and your cos theta. So you really need to be comfortable with those. So sine theta times your hypotenuse should give you your d1x. And again, we have everything given here, so we know sine 25 degrees times your hypotenuse, which is 42. And you just simply plug that in your calculator, and I get 18. So that's your d1x right there. So we can fill that in your table you've made before. You've got 18 here. That's your d1x. Similarly, we can work out same thing for the y component. So your d1y. Again, really simple. Looking at your picture, you should be able to figure out the trig relationship. So in this case, we don't have a d1y, we have an angle, and we have the hypotenuse. So again, you can use your cos theta times your hypotenuse. Just remember, you should be like, your cos theta relationship is your cos theta is your adjacent over hypotenuse, right? So you don't have your adjacent, which is your d1y, and you have your hypotenuse, so you just take that over there to isolate for d1y, and then you just solve it. So again, cos 25 times 42, and plug that into a calculator, and you should get 38.06. So just 38 is good enough for us right now. So we can go back to our table, and we know the y component for number 1 is 38. So we've got component number 1 figured out perfectly. So let's move on to component number 2. Component number 2, it's a little bit more tricky. It's not component number 2, my bad. It's pretty easy, same thing. We have your d2y in your south direction, so d2y, and you have your d2x, again it's in a positive east direction, so d2x, and 37 kilometers is the actual displacement. So this is 37 kilometers. This of course is a 90-degree angle, and this is again a given angle of, I believe, 42 degrees. So 42 degrees. Again, very simply break it up into your vectors. So starting with your d2x, very simple relationship. It should be sine 42 times 37. So very similar to before. And let's get about 25. So again, plug that into your calculator. Go back to your table before you forget. So 25 right here. D2y. Again. Now, something is a little bit different here. We are going to, we're in the south direction here. So since you're up, upwards y is positive, your downwards y is negative. So we have a downwards y here. So we're going to put a negative in front of your entire solution here. So negative cos theta, which is 42 times 37. Now you have to do this, otherwise you're going to, because this is all vector problems, so you're going to have to use this to define for your, to account for your direction. So don't forget to put in the negative sign there. And again, this comes out to be negative 27. So don't forget to put that in your table. So you've got vector number 2 done. Vector number 3. Vector number 3 was, I believe, 26 kilometers south, 12 degrees west. So we're going west, so we're obviously going towards the left-hand side. And we are going south, so it's going down. So this is D3Y. And this is your 26 degrees. Sorry, not 26, 26 kilometers right here. 26 kilometers. This is your 90-degree angle. Now it says 12 degrees, but obviously it's not 12. Your 12 is from your actual axes you're making here. So this is 12. And this would, then obviously this would be 90 minus 12, right? Because they're complementary angles. So we'd have 78. So when it says 12, please just don't plug in 12 here. 12 means from the entire right angle this line makes. So then hence the leftover angle would be 90 minus 12, so 78. So let's solve for d3x very simply. So d3x would be, now don't forget, it's going to the left, so negative cos 78 times 26, and this gives me negative 5.4. So again, really quickly go back to your table and plug that in, and you'll see why. Again, d3y, remember we're going down again, so negative sine 78. I really should put the degree sign here just to be, so you don't get confused, times 26, and this gives me negative 25. So this is negative 25 right here. So again, make sure you've got your trig things clear. You've got your trig relationships clear over here. If not, please go back and review those. If you're really stuck on those, please comment in the box below and I can go through basic trig relationships for you, but if not, then it's all good. So we have basically we've broken down all our components, and we have this over, so we can sum it up. So you sum up the x components, so 18 plus 25 minus 5.4, I actually end up getting 38. And again, for your y component, so you have 38 minus 27 minus 25, you get a minus 14. So what do you do with these numbers? What we do with these numbers is we actually, I'm just going to do it in the corner here, we actually make another vector component. So we have, this means it's going 14 in the south direction. So we're going 14 in the south direction, and we have, this means we're going to the east direction because it's a positive number, and we have 38 going to the east direction. Obviously this is not to scale, so don't worry about that. We have this, and we don't actually know what this is. This is your final displacement, if you will, and we don't know your angle here. So I would say, so you simply find out df, it would be your Pythagoras relationship, so 14 squared plus 38 squared, and that should give you 40 kilometers. For your angle, you should be able to solve that, so tan to negative 1 or inverse tan, 14 divided by 38, and that gives you 20 degrees. So that's your final vector component. It's 40 kilometers south, 70 degrees east. Perfect.